Welcome to Einstein DXB. Today we are going to solve numericals on momentum, conservation of momentum, and impulse. All these three terms are coming under the same equations. So let's get straight into it. The first question is the total mass of the train and its passenger is, let's highlight the values. That what are the values which we are going to use? Okay, the mass is given. Then we have velocity, or you can say speed. The train is traveling at a speed of 84 meter per second. Then you have time, 80 seconds. Then it slows down to the speed of 42 meter per second, right? So you have mass, you have two different velocities, you have time. Now let's see what you have to calculate. Calculate the impulse applied to the train as it slows down. Simply you have to calculate the impulse. Now which formula of impulse is applicable here? Because you have two formula of impulse. One formula is in the form of, let me write on here, impulse. The basic formula impulse is equals to force times time. That F is force and T is time. Another formula of impulse in the form of momentum is change in momentum. Now here you have to think which formula is applicable. This is very important because once you have a 2-3 formulas of same physical quantities, then you have to choose which one is applicable according to the given quantities. If we will see here, we don't have a direct force magnitude. We have time, but we don't have force, right? So what about the change in momentum? Yes, we have two velocities, we have mass. So it's better to pick the formula of impulse is equals to change in momentum. Okay, change in momentum means what? Momentum, final momentum minus initial momentum, right? Because whenever you are finding the change is always final minus initial. Okay. Okay. So final momentum is mv and initial momentum is mu, right? Because in the final momentum formula I'm using the v velocity, and in the initial momentum I'm using the u velocity. Okay, now let's substitute the values. Okay, we have mass, so it's better to take mass as common, so it will be easy in the calculation. It becomes v minus u, right? So mass is your 7 5, how many zeros? It's 40, right? Multiply by v minus u. Yes, here now which one is final velocity and which one is initial velocity? If I will see the statement, let's check again. The train is traveling at a speed of 84 meter per second. It means the initial speed of the train was 84 meter per second, right? Now after the driver applies the brake and the train takes 80 seconds to slow down to a speed of 42 meter per second. So 42 meter per second is your final speed and 84 is your initial. In the formula, your final minus initial, it means 42 negative 84, right? Don't take like the bigger magnitude of speed is the final one. No, according to the questions you are going to decide that which one is initial and which one is final. Okay, now if you will do the calculation in your calculator, let me calculate here. Okay, always write the answers in the form of power because that is the standard form of writing. Okay, so the final answer is, you can check in your calculator, it's 3.2, sorry, let me make decimal, into 10 power 7. Now what is the unit of impulse? What is the unit of impulse? Impulse, if I check the formula of impulse, you can automatically understand the unit, because if there is no unit written after this magnitude, then you have to write the unit. Okay, in some cases units are mentioned in your papers. Okay, so what is the unit of, we pick the formula of impulse is equals to change in momentum. It means whatever the unit is of momentum, that unit is for the impulse also, because impulse is equals to change in momentum. You can also write the unit in the form of the force and time. The unit of force is Newton and the unit of time is second. So you can also write the unit of impulse as Newton second, or you can write the unit of momentum. So I'm writing here the unit of momentum, that is kg meter per second. Okay. Okay, let's come to the second part of this question. Calculate the average resultant force applied to the train as it slows down. Okay, now you have to calculate the force. No worries, we can pick this formula. Impulse is equals to force into time. Okay, because now we have to calculate the force. So I'm writing here the formula of impulse is equals to force into time. Let's put the force on one side, rest of the terms on another side. So I'm writing the force on one side and impulse over time, because this time will go in the denominator, right? If I will put the force on one side. Okay. Now how much is the impulse? You have already calculated the impulse in the first part, right? Substitute the value of impulse from the first part. Okay. So in the first part, our impulse value is 3.2 into 10 7, or the time is how much? 80 seconds. Okay, so the final value is approximately 3.9 10 power 5. Okay, now again, unit, the unit will be, because this is force, so the unit of force is newtons, simply capital N. Okay, so this is the first question on impulse. Okay, I hope the impulse part is clear to all of you. So let's come to the next question. This question is from the Newton's third law. So here we are not talking about the Newton's third law. That's why I'm leaving. Come to the next question. Okay, the next question is, this is the next question. 0.80 kg of water is emitted in the jet every 6 seconds. Okay, now we have mass. Let's highlight what are the given values. We have mass, we have time, we have velocity. Okay, so these are the given values. In any question, once you know the given values, right, and unknown value, you can automatically, it is easy to recall, okay, which formula is applicable. For example, if you have to make some recipe, right, and in front of you all the ingredients are there, so you can easily predict that, okay, with these recipe, I have to, with these ingredient I have to make this recipe. So same thing with physics also. You are, when you know the given values and the unknown values, right, it is easily to pick that, okay, which formula is applicable. Okay, let's get straight into this question. Calculate the change in momentum of the water that is ejected in 6 seconds. Change in momentum. Okay, let's write down the formula. Change in momentum ejected in 6 seconds. In 6 seconds. Okay, so first change in momentum is P final minus P initial. Okay, P final formula is mv and P initial is mu. Okay, now what is the final velocity of the water and what is the initial velocity? The initial velocity is, try to understand here, initially the water inside the this one, it was at rest, the water was at rest, and the finally when the water is ejecting from here, then the velocity of the water is 0.72. So in the case of the water, if we will talk about the change in momentum, then initial momentum of water was zero. Why? Because the velocity was zero inside the this pipe, you can say that, or water pipe or water tank. The water was at rest. I'm not talking about the specific particle molecules and all. Okay, but still the water was at rest. But once the water coming out from this pipe, then the velocity of the water was 0.72. So my point is that initial velocity is zero. That's why initial momentum of water is also zero. But the final velocity of the water is 0.72. So the mass of water was how much? 0.80. Let me write that. Yes, 0.80 multiply with 0.72. But the negative, zero, because the initial momentum is zero because of initial velocity, right? Now let's multiply and see what is the change in momentum. So it's coming 0.58 kg meter per second. Okay, fine. Let's come to the next part. Fine. Calculate the magnitude of the force acting on the model because of the jet of water. Okay, so what we are supposed to calculate here, we have to calculate force. Fine. Because of jet of water. Okay, magnitude of force. You know, the word magnitude means numbers. So you have to tell the force in the form of 20, 30, 40. Whenever the word magnitude is mentioned, don't write the force is increasing or decreasing. Magnitude means you have to calculate the force in the form of numbers, right? Now, which formula are you going to apply here? You have to calculate force and you have some change in momentum, right? So you have change in momentum, you have to calculate force. So pick a formula in which change in momentum and the force is coming, right? And time. So what are the given things? You have change in momentum, you have calculated in the first part, right? And you have time, change in time, and you have to calculate the force. So these are the given values, and this one you have to find. So what do you think, which formula is applicable? See, F is equals to change in momentum over time. Change in time also you can mention, or simply time you can mention, okay? This delta is for the change. Delta is for the change, right? Okay. This is from the, actually this formula is from the statement of Newton's second law, but it is coming under the topic of momentum also, because the force is related to the momentum. Okay, so force is equals to change in momentum over time, right? So change in momentum, we have already calculated change in momentum in the first part, 0.58. So I'm substituting the value from the first part, and the time is 6 seconds. Okay, now let's calculate how much it's coming. 0.48 over 6 is 0.096 Newton. Okay, so this is the second part. Make sure that whenever you have 2 3 parts, don't forget about the, after solving the first part, that there is no relation with the second part. Most of the time in the second parts you have to use the first part some values, right? So it should be like mostly the parts, the first, second parts, third part, they are connected to each other. Okay, so these two are the questions related to impulse, momentum, change in momentum. Let's come to the next question. Okay, this is interesting question because this is on conservation of momentum. Yes. Let's try to understand first conservation of momentum, because if in front of you, if something is like before collision, after collision, it means it's talking about the, the concept of conservation of momentum or principle of conservation of momentum. This is interesting. Let's highlight what are the given values that you have. Okay, you have the mass, you have mass of two bodies. Okay, keep in your mind, whenever the two bodies are colliding, okay, the mass will remain same, means here or here the mass will be the same, the mass will be same, 3.2 kg of A body, and the B body mass is 1.6 kg, right? The mass is not going to change. This is the scenario of before collision, this is the scenario of after collision, right? Okay, the velocity of A body before collision is 4 meter per second. The velocity of B body before collision is 0. Why 0? Because the body is at rest before collision. The B body is at rest before collision. Okay, come to the next, after collision. After collision, now A body is moving with 1.5 meter per second and B body is moving with sorry, B body is moving with 1.6. It's the mass is 1.6 and moving with V velocity. Okay. Okay. Let's see what is the question, because these are only the, the given values. So what we are supposed to calculate. Okay. So the first part is the momentum of A before the collision, right? So we have to find out momentum of A before collision. Now, in this question, it's not necessary like from the first part you have to, um, you know, calculate or apply the principle of conservation of momentum. In most of the questions in first two parts, you have to simply calculate the simply first part or second part of the collisions. Okay, so the momentum of A before the collision, right? The momentum of A before the collision. Yes, A. We are talking about momentum of A before collision. So we are going to take only this values. So momentum of A before collision. Sorry, let me fix this. P is equals to mass times velocity. But momentum of A. Okay. So what is the mass of A body before collision? That is, sorry, 3.2, 3.2, and the velocity before collision is 4, right? The velocity before collision is 4. Okay. So how much will be the value? Let's calculate this. It's coming 8, 12.8. So, and what will be the unit? That's kg meter per second, right? Okay. Okay, we are done with the first part. Yes, second part is pretty interesting because in the second part you have to use the conservation of momentum. Okay, so in the second part we have to find this V. This V we are supposed to find out. Okay, now for finding the V, we need to use the principle of conservation equation. This equation is very important. First, let's recall what is the statement of conservation of momentum. The statement of conservation of momentum is total momentum before collision is equals to total momentum after collision. After collision. This is the statement of conservation of momentum. Now, what do you mean by total momentum before collision? Let me explain you what you mean by total momentum before collision. Total momentum before collision means the momentum of A body plus the momentum of B body. This is called the total momentum. Let me write here first. Yes. Move to what I said, total momentum means momentum of A body plus momentum of B body before collision. Okay. So momentum of A body is again mass times velocity of A body. Okay. Plus mass times velocity of B body. Right. This B body. So mass time velocity of A body is mass is 3.2 and velocity is 4. And mass times velocity of B body is mass is 1.6, but the velocity is 0 because the body is at rest, right? So this one 3.2 into 4, 8, and this is 12, 12.8 plus what? This one becomes 0. So the momentum before collision is how much? 12.8. So I'm directly writing here 12.8 is equals to total momentum after collision. Let's see total momentum after collision. This is the after collision story. So after collision is total momentum after collision, momentum of A body plus momentum of B body. So momentum of A body is 3.2 into 1.5 plus 1.6 into V, right? Okay, so let's see 3.2 into 1.5, how much it is coming. It's 4.8. Yes, 4.8. So 4.8 plus 1.6 into V. Okay, so let's write down here 4.8 into 1.6 V. Okay, now let's solve it. 12.8 negative 4.8 is equals to 1.6 V, right? It's coming 8 is equals to 1.6 V. Then V is equals to 8 over 1.6, right? So it's coming how much? 5 meter per second. Okay, so this is the part on conservation of momentum. Okay. Okay, so that's all for today. So we did questions on impulse, conservation of momentum, and this conservation of momentum is very important. That's all for today. See you in next video. Thank you so much for watching.